So good morning, good afternoon, depending on where you are. Welcome to Coral Live here at the Bermuda Aquarium. Very, very happy to have Winston with us, who's one of the aquarists, and I'm going to struggle with that word all through this. I don't know whether you struggle with it too, but to explain to us a little bit about what's involved in running an aquarium. And I've just been learning just while we're setting up this call. This is an open aquarium.
Yeah. So you've got open systems and closed systems aquariums. So here in Bermuda, we're pretty lucky. You can pump the water into the aquarium, and then water gets pumped out. So basically, your water quality is going to be good as your ocean. Here in Bermuda, we've got some pretty awesome water quality, which allows for some pretty awesome exhibits. Whereas you've got closed systems. Closed systems, basically, the water stays in the system. So in those, typically, you're making your own salt water. Water chemistry and quality and that sort of thing are a lot more important. And you can manipulate those things. So if you want a tank have fresh water in it or salt water, you can obviously add more salt water, add more fresh water to them, change the temperature, change the salinity, and that sort of thing. And that allows you to have just a greater range of exhibits and that sort of thing in animals.
Fantastic. And so you're one of the aquarists here.
Yeah.
What does being an aquarist actually mean, and how did
as an aquarist, we are responsible for the fish. So all the fish here at the aquarium we take care of. So that includes maintaining the exhibits, improving the exhibits, watching for the fish quality and that sort of thing. Going out collecting, which is always fun. So we did a little bit of that today. So we're out. So that kind of entails diving, feeding, cleaning the exhibits, pretty much anything you would associate with your aquarium at home and that sort of thing, just on a greater scale.
Amazing. And so you're out getting some new exhibits today. What kind of things were you looking for today?
Yeah. So when you've got an aquarium that you're maintaining and that sort of thing, you obviously have different corals and different fish that you want in your tank. When it comes to those sorts of things, it's not exactly like a grocery list. You can't just say, oh, I want one of these, one of those, one of those. You kind of just have to go out, decide on a location for one. So you have a team of typically 3 people and decide, or basically not decide, but try and find what you can, really. It kind of depends on the day, what you kind of sort of come across. Today we focused on a lot more inverts and corals for our tanks. And hopefully in the coming weeks we'll be able to focus on getting a bit more fish as well.
So you throw away this sort of inverts word. I mean, for our younger audience, what kind of things does that mean?
So instead of fish, which are vertebrates with a backbone and that sort of thing, we're looking for corals. We're looking for sea urchins. Pretty much any other living thing that's not a fish or that's not a fish, really. So octopi would be classified into that.
So your crustaceans, so your sort of
crabs, lobsters,
crabs,
and that sort of thing. Yeah. We were kind of a little restricted for time this morning, so we had to kind of focus on, basically make a decision and focus on where we wanted to focus our time. And so that's what we decided on. So corals we got a lot of, and some rock and that sort of thing for decorations and some of the exhibits.
Fantastic. So we've got a lot of questions here from a school in Sydney,
okay.
And this is a lot about sort of the wider sort of issues of scientific research and some coral bleaching, which we might leave to a little bit later, on in the chat. But how did you just? And we've got some great questions coming in also on sort of like sort of aquariums work. But before we get into that, how did you go? I mean, you grew up in Bermuda.
Yep.
And how did you end up working as an aquarist rather than anything else?
Growing up in Bermuda, you're surrounded by the water. So it's like I spent large amounts of time poking around in tide pools, swimming, which eventually led to wanting to scuba dive and that sort of thing. And when you're passionate about pretty much anything, you're going to want to spend or do more in that field and kind of just do whatever you can to get involved in that more. And just like becoming an aquarist, marine biology was kind of my focus. I was always, I think from like the age of 8, I was kind of like marine bio. This is what I want to do. And eventually went to school for it. And then realized marine biology wasn't exactly what I wanted. I wanted a bit more, a broader scope on it. So I ended up studying environmental science and geography, which I really loved. It allowed me to kind of still focus on marine bio aspects that I loved, while still kind of doing a bit more on the environmental side of things. But when it came to getting a job as an aquarist, I was shortlisted for another position, and then they mentioned that they had this position available. It was never something that really occurred to me, to be honest. And then kind of looked it up. Well, not really looked it up, but kind of knew what it was and what it entailed, and decided to take advantage of the opportunity. And since then, I've gone to Toronto to do the same kind of work, and now I'm back here, working at the aquarium here, which I couldn't be happy with.
Amazing. And I mean, this is one of the largest tropical coral sort of exhibits, aquarium in the world.
In the world, one of the biggest living coral exhibits in the world. And typically with things like that, like again, we're pretty lucky to be here in Bermuda, where we can again pump water in, pump water out. It makes it really easy for us to kind of grow and maintain corals here.
Because you've got that changeover of nutrients,
and it's all naturally done. Whereas other aquariums and that sort of thing, they'll have exhibits and have living coral exhibits, just not on this scale. And that's because when you're dealing with closed systems, it's water quality and chemistry and that sort of thing are a lot more finicky for the corals.
So we've got one question coming through from Ricardo. It is that he's saying, well, if I have a domestic aquarium, can I put any of these animals in there? Can I have parrotfish and all this kind of stuff?
You absolutely could. Again, it's a lot more challenging to have those sorts of things. So I know a lot of the time hobby aquarists in their homes and that sort of thing, they'll have typically they'll have the tanks for the summertime. Even the summertime, the water's a lot warmer. Fish typically do a lot better. It's a lot easier to kind of maintain. Whereas in the wintertime, it's not so much. So they'll usually break down their tank and release the fish. Again, depending on where you are, it can be an easier thing, and other places not so much.
Okay. So I mean, a lot of questions coming through on coral protection, which I keep to the latter half of this. What we might do is this tank looks quite amazing. What's involved? And I sort of almost, I don't want to drop the computer in the water, but we're going to take you in here in about 2 minutes. But before we go in, just tell us what we might see if we, or what this whole tank's about.
So this is the North Rock tank. So we're on the top of it. It is open to the light. So we've got living corals in the tank. Those corals depend on natural sunlight, or just sunlight in general, artificial light as well. Natural sunlight is the best, obviously. So it is open to the elements, rain, and that sort of thing. Inside the tank here, 2 parts actually. So you've got a division on one side. It's slightly smaller. Can't really see it, but it kind of houses a lot of our smaller fish. So you've got a lot of our parrotfish, our butterfly fish. Basically keeps the smaller fish away from the bigger fish on this side. So on this side, there's some nurse sharks in there. There's horse-eyed jacks. There's a black grouper in there. Spike, our great barracuda, is also in there. His name's Spike. So this basically the North Rock exhibit has kind of been designed and developed to mimic what you'd see about 11 miles offshore Bermuda, so the northernmost point of Bermuda. And so that's basically what you see on the reefs if you were to go out about 9 to 11 miles.
Okay, I think we're smiling for a thumbnail apparently. That hopefully has been done. So what we're going to do now is, if I can just come right here. Slide this on and hopefully they're drop everything. Just to say, we haven't left. We're still here, and what we're going to do is there's a lot of great questions on the wider coral ecosystem, which we're going to come to at the end of the talk. And I know that there's a school in Sydney that's very interested in that. But what we're going to do now is find out how amazing everything is before we talk about what's happening and potentially what people can do at home to try and save it. So I'm going to first go live on here, and we've been using this sort of tandem system, so hopefully in the office in London they'll be able to tell us where to go. Or how yours is very beautiful. And so we're live on here. It's incredibly difficult to see. But what we're going to do is we're going to turn this camera around very shortly and put it in the aquarium. And I hope that's okay. I hope this is going to put oily stuff on here. And this will describe some of the things that we might be looking at down below, and if there's anything that looks awesome, point us towards it. Yeah. So hopefully if I turn this around, that button works. Right. And then actually that's what's coming out this way. And then the microphone is here, we have cameras here, and try and get the camera in the water and the microphone out of it.
All right. Yeah.
So what do you have a look at?
So I guess the most obvious one at the bottom here is one of our nurseries. So there's 3 nurseries in the tank. They typically hang on the bottom. So they've got a set of bony plates on the bottom of their mouth with a set of bony plates that they use to typically kind of crush corals, or not corals, sorry, crabs and lobsters and that sort of thing. So they use that those plates to kind of crush food and inhale it. So not typically ripping and tearing like your normal fish. Okay. Those guys can actually pump water over their gills. So I guess it's a common misconception that all sharks have to constantly swim. These guys do not. So these guys have bugle pumps that basically again allows them to pump water over their gills, whereas the common swimming sharks will have ground ventilation. That's basically they usually have to okay. These guys here, those are horse-eye jacks, so they're commonly mistaken for tuna in the tank. We do not have any tuna in the Pacific. Tuna are a lot bigger, a lot more fish than what we have here. We've got some great snappers at the bottom there, kind of hanging out just above the surface. There's 3 hanging out kind of together. Just over there, the cool bright blue angelfish. Well, kind of gone down, unfortunately.
And the coral, right?
And the coral, yeah. The coral is probably one of the more, I think they're kind of one of the cooler parts of the tank, because they are little. Like I said, it is open to the sunlight. You've got some goldenrods that hang on this side. Those guys typically like a lot of flow. That's kind of where you see them off of rock faces and that sort of thing, where it's not as turbulent or surgy, because they typically will break off in that sort of strong wave action. There's a couple of brain holes in the tank, kind of at the base of the rod. Yeah, might not be able to see them. But those guys typically do well in a stronger surge environment. There's a lot of barriers and ways to the brain hole. The sand is actually pink, not really here. It's very coarse pink sand with a single-celled organism called Polyp that lives basically through the holes, and then once they die, they fall to the bottom. And parasites are typically kind of, or other things, will process that sand with a lot finer.
So the other thing I've seen in here is balloon fish.
Yeah, the pucker, yeah.
Pucker fish, balloon fish. So in case that comes back, I've got the photographs which I can put online after the call. But tell us about the balloon fish and pucker fish.
Yeah, so we've got one in here. He's pretty cool. So as a defense mechanism, he's got a whole bunch of spikes lining his body. And as a defense, he feels like he's under attack or being threatened. He can suck in a whole bunch of water really quickly. And basically look like a very big, spiky basketball. Making it very, very difficult for him to be eaten or getting into. He does that every so often in the camp. Kids often try to make him tough. It's not something that he would do regularly. He has something that he has to feel like he's really in regret to do it.
So then,
Here's Spike.
Spike straight away. And the main thing, so with Spike with Giant Barracuda, you can sort of head on to probably miss the barracuda in the water.
Yeah. So a lot of the fish in this tank are pelagic, open water swimming fish. Not the kinds you would typically see in the colorful, more reefy sections of the tank. So a lot of the fish in here are a lot, I guess, just not as colorful, and that helps them have camouflage. So what Dean was saying earlier, well, just now, is that if you look at your head on, he's going to blend in really well with the blue into the water, and kind of almost invisible because he is kind of so blue in color. The most of the fish, like I said, will be fairly silver in color on the side or dark.
And when we talk about like because they come to the reef because there's so much light supported by the reef.
Yeah. So so pelagic just means open water swimming fish. So your tunas, your Marian, and that sort of thing. But barracudas as well, like I said, they will come to the reef because the reef has so much life in it. There's tons of fish, tons of food for the fish
Fantastic. So this is just to show, and if you were to dive on North Rock, is this kind of thing you see? Is this sort of quite simplified?
Yeah, exactly. Yeah. So this is, like I said, this was designed and developed to mimic what we see. So it's almost bringing North Rock to the aquarium. So they decided to, on a chunk of the reef, to kind of mimic, this way. So it's almost just taking like a little snippet of it and bringing it to the aquarium. Most people, surprisingly, it's only 9 miles off of Bermuda, but a lot of the media don't get the chance to, or even tourists as well, don't get the chance to go out there. It's usually not one of those things on their list. Yeah, we were able to bring that here to the aquarium. Kind of cool. So this is pretty much exactly what we see coral-wise, fish-wise.
It's like you walk there, like that again. Yeah. And you get in here in front of the
Yeah, so all the aquariums are dive certified, so they're required to, part of to get into the tank, we do a checkout guide to make sure that you're comfortable in the tank and that sort of thing, and we do clean the tank 2 to 3 times a week. So that involves getting in, doing the acrylic, the window on this side, and then there's 2 windows on this side that we also do. Okay. So we go in and we spend typically about an hour or so cleaning.
I still got another shot of one from there as well. We'll come back. Yeah, my neck was just like cramp up and go. We'll come back here. So the stream from underwater has decided to die, but hopefully I saw quite a few good shots there. Winston was just explaining, and I'll just turn this around and get you a bit more shot there. You know, the 3 nurse shots in here, and yet you're getting in to spend an hour cleaning the glass or perspex or acrylic, whatever when you're doing your cleaning. They have a reputation. Is that deserved?
Absolutely not. I think sharks have one of the biggest.
So we're just looking. We've got a nurse shock down here. I mean, we wish you could just jump in with us.
Yeah, sharks don't along with barracudas don't really get the reputation they deserve. Sharks really don't want to eat us. We're not really on their menu. They would much rather a big, fat, juicy seal than us. Sharks don't have the greatest eyesight, so typically what happens is they make mistakes in biting us, and the typical attacks that you hear of. Often it's on a surfboard or a paddleboard and that sort of thing, or at the top of the surface where if you kind of compare a seal and a human, they look very similar.
Black wetsuit.
Yeah, exactly. So it's easy for a shark to kind of make those mistakes given murky water. A lot of attacks seem to happen at dusk, so it's not the greatest light out, and those sorts of things. So unfortunately, those mistakes do happen. More often than not, when a shark does bite it first, it's just a inquisitive bite. Yeah, so they're kind of seeing what it is. So they're trying it out, and then usually when it comes to a human, they're like, oh, they let go because they don't like the taste of it, of us. But unfortunately, some people do die, and that's more so because of just generally the size of the shark versus the size of a human. Sharks are very big animals. Sharks don't kill as many people as you think as well. I think more people are killed by vending machines than sharks.
And cow attacks.
Cow attacks. More people are killed by selfies, taking a selfie, than they are being killed by a shark every year, which is
okay. So cut down on those selfies. So I mean, just wait for the emergency vehicles to go past. But there are a number of questions here about. Apologies for the sun and the angle and everything else. We're dealing slightly with what we have today. So a lot of questions coming through are about things like coral bleaching. What can students do? So what kind of, maybe explain coral bleaching and maybe some of the other threats facing the reef here.
So when it comes to threats facing the reef, the two bigger ones, I guess, would be coral bleaching and ocean acidification. Coral bleaching basically is the removal of the zooxanthellae, the algae that makes the coral grow, that allows the coral to grow. It converts the sunlight into energy for the coral polyp itself. So when you've got extended periods of warm water or stressors, so cold water as well, but more commonly now is warm water. So extended periods of warm water, typically about 1 degree Celsius or 2 degrees Fahrenheit, above their maximum average. So for extended periods of time. So if a coral is used to 80-degree water, when that water is 82 degrees or 83 degrees for an extended period of time, it might not seem like a lot, but that's enough to stress the coral out to where the zooxanthellae leaves. Once that algae isn't there, it produces it basically exposes the skeleton of the coral. So we've got a brain coral here. So essentially, when a coral bleaches, this is kind of the leftover, or the remaining, what you'd see.
So this is the mineral structure.
This is the calcium carbonate structure that the coral polyps produce. So they secrete a calcium carbonate as they grow, and once that algae that kind of covers that protection leaves, they aren't able to produce that calcium carbonate structure as well, or pretty much anymore at all, leaving along the skeleton here. You can kind of see why we call it bleaching, because it's all very white.
And so what does that mean when because, okay, some of the coral died, what does that mean for the rest of the life on the reef?
So coral reefs are home to about 25% of all fish life, marine life. So you can imagine, if that's your home, 25% of marine life lives in coral reefs. If that coral reef structure isn't there, or isn't operating to its full potential because of stressors like global warming and that sort of thing, you tend to lose a lot of the life that depends on the coral reef. So a lot of small fish, or the bright, colorful fish that live on the reef that eat some of the other green hairy algae and that sort of thing, like the parrotfish, they depend on those coral reef structures. And if that's not there, you don't get a lot of the smaller fish coming in. A lot of the big fish rely on those small fish. So it's a fairly kind of snowball effect that happens. So as you can imagine, that coral reef structure would quickly cease to live. And not only that for the fish itself, but we also rely on fish. Fishermen and that sort of thing go fishing, and they need to, they depend on catching fish for their livelihoods and that sort of thing. So if those fish aren't there, one, sharks and that sort of thing aren't there to, or aren't able to eat, other fish aren't able to eat, and so we are also unable to eat or live off of that ecosystem as well.
So all in all, coral reef's important. That carbon, increased carbon in the atmosphere, driving the warming, driving the acidification,
Absolutely.
really harmful, not just to the coral,
but to us as well.
but to us and the entire ecosystem as well. Amazing.
Yeah.
Well, not amazing, but you know,
it's you wouldn't think that such something that we don't live off of directly impacts us so much. Yeah, I think that's kind of the biggest thing. We don't think about those things, but they do play a really, really big role in other people's lives necessarily, not necessarily ours specifically.
And when you've been out collecting or on previous trips on the reef, have you discovered a new species?
I personally have not. I know other people that have, and that's kind of cool. It's usually like a shrimp and that sort of thing that they found.
Or algae,
something small. But I think there's still lots out there. I think we've explored more space than we have of our oceans, and they're right there. So there's definitely things out there, and I think, and deeper things are a lot deeper that we can't typically access as well. But I would love to discover something new. I think that would be kind of cool, actually. But unfortunately, I think most people have discovered most of the biggest things that are out there.
So we've got some questions through from Angela McCritchie. We're interested in finding out more about the life cycle of coral and sort of its growth rate.
Yeah. So corals they grow very, very slow. I think it's only a few centimeters each year that they grow typically in optimum conditions. Basically, there's two ways for corals to reproduce. So they can fragment. So that's essentially if a coral, one of these corals or any coral really, breaks in half, you get two genetically identical pieces. And given the right conditions, those two pieces can grow into two individual structures themselves. And then there's also the sexual, like reproduction. So asexual would be the fragmentation, essentially. And then you've got reproduction, which is the producing of a sperm and an egg sac or bubble, basically, or separate sperm and egg bubbles that are shot off from corals, typically at nighttime. They do these mass spawning events, and basically what happens is simultaneously almost corals release their sperm and eggs into the ocean, where they will hopefully interact with another sperm or egg, come together and fertilize and settle onto a suitable spot for the coral with adequate light.
Nice and light, hard, normally a hard rocky bottom, potentially some maybe a dead one of these.
Yep.
and then that starts the whole process.
And that will start the whole process again. Takes a very, very long time. And you can imagine with things like global warming, it makes it a lot increased difficulties for the corals to build their structures again. But that's essentially the life cycle of.
And something like this is about 15, 20 years old, or maybe
even greater than that, I would imagine. Possibly about 15, 20, I would imagine. But it, honestly, I wouldn't even know. I'd probably ballpark it in the estimate of 20 to 40.
Okay.
But yeah, they grow very, very, very slowly. When you're out in that sort of thing in the wild, you kind of have to be mindful of where you're stepping and not to break off things. I know a lot of the time people come to places and they see a pretty piece of coral that they want to break off, and in doing so, they
that sort
right
of
there,
20,
yeah,
30
that
years
20 plus years just is officially ended there. Even.
Yeah.
Chances are it's not going to get into water soon enough, and that coral can quickly die once it's exposed to air. So even when we're collecting and that sort of thing, or other aquariums, they often wrap them in paper towel and newspaper, just kind of help protect the algae and the coral itself from being exposed to air too long. That's kind of how we.
Is there coral in every ocean?
There is coral. There is a coral in every ocean. I believe there's coral in every ocean. Typically, you'll find different corals for one. So you've got subtropical climates like Bermuda, where you have corals that can withstand very narrow, a lot more narrow ranges of temperatures and that sort of thing. Deeper, so up to like 6,000 meters, you have corals. They're not algae-producing corals like these ones, but they rely on the nutrients that are in the water as opposed to converting sunlight like the zooxanthellae.
So we've got these tropical and subtropical coral reefs. What we sort of typically think of as a coral reef, which are in these sort of like this band of shallow, clear
around the coral reef, around the equator
and tropics and that kind of area. But then we have this other type of coral, which is a deep cold water coral, and it doesn't move in light because it doesn't have that photosynthesizing algae inside it.
That's exactly.
And those can be all over.
And those can be all over. Those convert, those convert just like how plants do in a way. Well, no, not really like plants at all. They're filter feeders essentially. So they're
more like the anemones
and that sort of thing. So they're straining water that passes through them and kind of collecting the nutrients that are in the water column as opposed to
plankton, sort of
plankton,
tiny plants, tiny
that
animals,
sort of thing.
copepods, type of sea plankton and small crustacean there. And so, I grew up in Scotland, and famous Lophelia was the type of deep cold water coral of Mingulay in the Hebrides. Very proud of our coral reef in Scotland, although many people don't know about it because it's deep and cold. Much more famous here in Bermuda. So next questions. What is the biggest coral? What is the smallest coral? I think we might even be talking about the sort of polyp sizes.
Polyp sizes, yeah. So I think the smaller polyps hang out in the size of millimeters, where you get some polyps the size of about a meter or so wide. So the polyp itself can range depending on the type of coral. I believe the big ones are mushroom corals. Whereas the smaller polyps are typically these ones. Starry corals are very.
You've got the lesser star coral here, which is. I think we might even have a sample. Maybe I'll just reach over for you here. So we can just show you just on that sort of lesser and greater star coral the difference in polyp size.
Oh yeah, there you go.
And I'll hand those over to you, Winston, just to hold up to the camera, just to give a view.
So so you've kind of almost got like a zoomed in. Oh, you can see it. It's almost like a zoomed in view of what you'd see on this, but a slightly larger polyp. So each individual circle is a coral polyp. On these guys, the lesser star corals, don't really see them as clearly, but each little dot is essentially another coral polyp in itself. So polyp sizes can vary quite drastically.
I know you get these big sort of mushroom corals with a single polyp coral, and they're the only tropical coral that is not stuck in one place.
So they can actually move. Most corals, once they settle,
you can see on the bottom there, you can see how it's just stuck to the ground.
Yeah, so when a coral settles and finds a spot that it likes, it stays there and will start producing its calcium carbonate skeleton, solidifying it to that one spot. So yeah, more often than not, corals don't move from that spot once they started to settle. The mushroom corals, however, can.
Yeah, perfect. Great. So we've got a couple of teachers coming in from Egypt.
Oh wow!
And of course they've got the coral in the Red Sea.
Red Sea, yeah.
What's different from the Bermudian sort of coral reefs towards a reef that might be found in the Red Sea?
Well, for one, the currents. So Bermuda is one of the most northernmost coral reef system in the Atlantic. Whereas in the Red Sea, I feel as though I've never been there or studied it, to be honest myself. I would imagine the visibility being more of an issue for the corals.
I think one of the things I've really noticed about being on the reef here is the amount of soft coral that's making up the reef, which is very different from your sort of classic Indo-Pacific reef, which is sort of branching coral, a lot of the sort of like the Montipora, the sort of like those large plates and almost vases underwater. Whereas here we've got these lovely sea rods and sea fans, the soft corals. So the hard corals we have are these very sort of like boulder-like, sort of like more scattered brain and star corals.
Okay.
That's what I've seen here.
Yeah. So it kind of depends on where you are. So where you are would influence what kind of corals you'd be seeing in those sorts of places or in those sorts of locations. So typically on your boiler reefs where there's a lot of wave action, there's a lot of movement, you want something you're going to expect to find stuff that's a lot hardier, like your brain corals and that sort of thing. They can withstand a lot of wave action. Corals are very important to Bermuda because it's a rim of coral reef that kind of protects the island. So basically, a lot of the big wave action is kind of stopped by the coral reef, and that's due to a lot of these guys. If you were to put some of the rods and that sort of thing in a similar location, they wouldn't do as well. They'd often break off and that sort of thing, and that's just because they can't withstand that hard wave action.
And similarly, the sort of branching corals you might find in other reef systems, whether it's the Caribbean or in the Pacific, they wouldn't really suit this sort of, because we're in the middle of the Atlantic, basically, aren't we? We're sort of 600 nautical miles from the nearest land.
From North Carolina,
Yeah, so it's full force of ocean coming in on the reef here. And that's probably, as you were saying, that's changed the type of coral that you get.
Exactly. So it changes not only the type of coral, but the type of animals that you'd be seeing as well. So I guess for those that don't know, Bermuda is essentially like is on top of a dead volcano, an extinct volcano. So we've kind of built, or over time, this limestone cap has created Bermuda. So we're very isolated from any large landmass. So you get typically without the reef that we have surrounding us, we get a lot of those larger waves and that sort of thing. Surfing, for example, isn't really good here because those coral reefs kind of stop a lot of that big wave action that you'd expect, I guess, being located in the middle of the Atlantic.
Just a quick question here. What is your favorite type of coral and why?
My favorite type of coral? Never been asked that, actually. I don't think. I personally I like the rods. I just think they look really cool in an aquarium setting.
And sea rods,
the sea rods are the long finger-like corals that we have in.
And we've got this great one as well, which is more tangly. What's that one?
So that's actually a sea rod as well.
Okay.
So corals can retract their polyps.
Okay.
So depending on if they're feeling threatened or if something happens, so if like a big fish came and kind of flinged it with its tail, or if there's a fish sitting in it, that often happens. The corals don't like that as much. So as an added protection, they can withdraw their polyp into that skeleton to kind of protect it. That's kind of what we're seeing there. But probably the rods are my favorite, and that's more so because there's a trumpet. So we have trumpet fish.
Okay.
We have one at the aquarium here, but they're a long finger-like fish, and they can kind of hang out vertically and just kind of pretend like they're a rod, and it's kind of cool to watch them do that. And that's kind of what I associate with the finger corals.
Brilliant. And just nearing the end of the call, so thank you very much. But what can students do to protect our reefs? I mean, even if they're sort of quite far away from a reef.
I think the biggest thing is awareness. People often go places and either break off stuff, or if they're snorkeling and that sort of thing, or standing on the corals, and they don't realize, I guess, how sensitive and delicate these coral reef ecosystems are. So I think a lot of it's kind of just becoming aware and knowledgeable about the reef itself, and your impact. Obviously, things like global warming are a big issue, and that's a constant problem when it comes to coral reefs. And I think that's going to be ongoing for years to come, unfortunately.
So wherever you are, your carbon emissions are equally affecting.
Yeah, absolutely. So it doesn't really matter. Yeah, it doesn't really matter where you are. It's a matter of just kind of being knowledgeable, or even just being aware. Using your cars less, using transport, increasing your use of public transport as opposed to individual cars and bikes and that sort of thing, to just kind of help reduce CO2 emissions in a fight to try and reduce our impact that we're having on global warming and effectively bleaching and ocean acidification.
Wow. So there we are. It doesn't matter where you are, ride a bike, walk to school, share a ride. Let's move to electric. Let's try electric only if it's not coal, basically coal powered. So renewable based electric transport, that kind of thing, reduce our emissions and our consumption.
Yeah.
And that's going to help this amazing habitat that is estimated to be worth $1 trillion around the world.
Around the world, yeah. Oh, we've got one of our networks coming up.
Wow. So
we've got two big
sorry,
sharks.
Yeah. Oh, too late.
Come
back.
Yeah, maybe Sandy and Velcro are the two bigger nurse sharks that we have in the tank, and then the smaller one is Bethel.
Okay.
And we got her a few years ago. All females that are in the tank.
Okay, and that's on purpose.
I think it was more so what we collected at the time. Again, it kind of just depends on what you collect. The fact that they are all of the same.
There we go. I'll take this photo for you guys.
There's a cap line.
There we go. I think we're just ending the call, so I'll sit and we'll put the photos up on the District Explorer Facebook page in a jiffy, as it were. Well, I think unless this is the final question, I think it's going to say thank you very, very much to Winston. It's been a real pleasure. Thank you for introducing us to the wonderful world of the Bermuda Aquarium, to some of the life in here, to I mean, I never knew, and here comes everybody's coming to say hello at the end of the call. So we've got the
puffer.
I was going to have to really are coming to say hello. So I'll put these up later. But as we're just being distracted now, so we're going to say goodbye. Thank you so much for tuning in, and look forward to speaking to you later in the week if you're still involved on later calls. But please stay in touch, and thank you again to Winston. Thank you very much. Bye bye.